Yeah, so welcome back. I want us to continue and see how an electrochemical cell works. So we're going to uh, look at how different metals have different tendency to ionize. So in my example here, I've used the zinc metal, zinc ion half cell. I've connected it to the copper metal, copper ion uh, half cell. Then we are going to see how it works. So we're going to start with the zinc. So between our two electrodes here, we know that zinc has a higher tendency to ionize. It is more reactive than the copper. So as we say, when the zinc metal is dipped into this solution, the zinc sulfate solution, then the atoms on the surface of the zinc metal will lose electrons, and those electrons remain on the surface of the zinc electrode. Same case to our copper, it will behave the same, but now because zinc is more reactive, then the concentration of the negatively charged electrons will be higher in the zinc than in the copper. Remember, once the atom loses electrons, then it goes into solution. So in the solution now here, we are going to have more accumulation of the zinc ions. Zinc ions. So every atom is going to lose 2 electrons, and then it is going to go into solution. And because zinc has a higher tendency to ionize, then the concentration of electrons will be higher here, and so the flow of electrons will be from the zinc electrode to the copper electrode. So before we go to the copper electrode, so this is what is going to happen on this half cell. So in our zinc ion half cell, so this is what is going to happen. Zinc has a higher ability to lose electrons, to ionize. So we're going to have zinc, and then so our zinc is ionizing, it is going into solution, and it is giving us 2 electrons like that. Yeah, so these 2 electrons, they are in higher concentration as compared to the copper. Copper does not ionize more easily like zinc, so the electrons are thrown to the other side. So once the electrons come to the copper electrode, then the concentration of the negatively charged electrons increases. So on this other side, then we are going to have, so here we have the copper ions half cell. So because the electrons are flowing towards the copper electrode, then this is what is going to happen. So as these electrons accumulate, remember in our copper sulfate we have the copper ions. So those copper ions will be attracted by the negative charges of the electrons, and so this reaction is going to take place. So copper ions from the solution, from our solution here, is going to gain the 2 electrons, and then we're going to have copper solid. If you're very keen, this reaction, this is oxidation. The oxidation number of zinc was 0, but here it's going to +2. So this one has been oxidized, and the opposite is true. Copper has been used. So in an electrochemical cell, we normally have both oxidation happening on one half cell and reduction happening on the other side. And as a result, these electrodes will have different charges. So this electrode tends to have the negative charge, and we normally call it the anode. So at the anode, that's where oxidation oxidation takes place. So this now it is negatively charged, and that's why we call it the anode. The other one for copper, it's going to be positively charged, and therefore we refer to it as the cathode. So cathode is that electrode where reduction takes place. Reduction takes place. Yeah, so remember as we were talking about in the salt bridge, one of the functions of the salt bridge was to balance the ions. Which ions are we talking about? So as you can see, we said on our anode, we are losing electrons, and therefore we are forming the zinc ions. We have the zinc ions, and the electrons are flowing to the other side, to the copper, to our cathode. So on this side we are going to have an accumulation of the zinc ions. So that's why our salt bridge is soaked in our solution here, potassium nitrate, so that solution is going to bring a balance, because here we have positively charged ions. So in potassium nitrate we have the negatively charged ion, the nitrate, so they are going to balance the charges. So it is also possible to balance, to represent this half cell using a chemical or a small equation known as the cell diagram. So the cell diagram, so remember yesterday we said this is how we represent a half cell. Like in this case, we have the zinc metal and zinc ions. This is the half cell for the copper, for the zinc. And for the other one, we have the copper metal and the copper ions. So to connect the two, when we connect the two, then we normally call that the cell diagram. And this is how we represent it. On the left, we have the half cell that oxidation is taking place. That half cell where oxidation is taking place is always on the left, while the other half cell where reduction is taking place is on the right. So in our two half cells, then we've seen that zinc, in this half cell, this is where oxidation is taking place. So we write it as zinc. Remember we said the stroke is to represent the phase boundary where the potential difference is being experienced. Then we have the zinc plus. Then we've connected it to the other half cell, and in the other half cell, what is taking place? Reduction is taking place. So we won't write it this way. We will start as, so it is the ions that are being converted to the copper. So we write it as copper ions. The stroke to represent the phase boundary. Then we have the copper solid. This is aqueous. So this is how we represent the electrochemical using a small equation. It's simple. You see, zinc atom is losing electrons. It is actually losing 2 electrons. So it is forming the zinc ion. Then those 2 ions that have been lost are being gained by the copper ion. And once this copper ion gains the 2 electrons, then it is forming the copper solid. So with time, we should see something like this. We should see some solid, actually some brown solid, being deposited on the cathode. Are we there? Then on the other electrode, remember now this one, this electrode is dissolving, it is losing electrons, and once it loses electrons, it is forming the zinc ions. So on the other one, we should see it shrinking or becoming thinner, because it is dissolving. And what does this represent? So that represents the salt bridge. So this represents the salt bridge, to show that the electrochemical cell is complete. We are going to look more about this. So in the next lesson now, we're going to compare to measure the electric potential of different metals in comparison to copper. So specifically, like for this one, when you use zinc, our voltmeter should measure a voltage of 1 volt, 1.0 volt. So we're going to compare other metals using copper and see how that goes. See you in our next lesson.